Hi everyone! Today we're going to talk about operations with complex numbers. We started talking about complex numbers in that last unit, and we said complex number, right, it had that real component and an imaginary component. So for example, 2 plus 5i is a complex number. 3 minus I is a complex number, right? You can write a lot of different types of complex numbers, but in general, when we talk about a complex number, we'll just say a plus bi. A is your real component, bi is your imaginary component. Okay, so that's kind of the general terms when we talk about them. And so we can do lots of different things with complex numbers. We can add them, subtract them, multiply them, divide them. We're going to get into all of that. We actually can also graph them. And I want to show you how to do that because it is going to be on your assignment. This is the coordinate axes we use when we are graphing complex numbers. So you'll see the horizontal axis is your real axis. The vertical one is your imaginary. So I'm not sure if you can see it, but this is actually labeled I up here. Okay, so that's your I axis. So for example, if I was going to graph 2 plus 5i, I would go 2 on the real axis and 5 on the imaginary axis. Okay, 2 on the real axis, 5 on the imaginary axis. And then I would draw an arrow from the origin to that point, because when we're talking about complex numbers, we don't just plot the point, we actually draw in the arrow. Okay, it always goes from the vertex to that point. So I can have lots of different ones. I could have negative 3 minus I. That's the same as negative 3 minus 1i. So that would be down here. And then I would go ahead and draw in that arrow. Okay, so that's how you would graph an imaginary number. Let's talk about some special cases. Let's say you were just graphing, for example, 3i, and I asked you to graph that. That is the same as 0 plus 3i. So that would just be 0 in the real direction, 3i in the imaginary direction. Now, sometimes you'll see it just graphed as a point, but then when we're trying to find other things, we're actually going to use this whole piece graph. So you want to make sure that you graph that arrow. Okay, make sure that you do that. You'll plot the point and then graph the arrow. When they do it in the assignment, they don't always plot the arrow, but I want you to make sure that you go ahead and put that arrow in there. So here for 3i, it would just be an arrow up like this. Okay, same is true if I just asked you to graph 4. In this axis, it would just be 4 plus 0i, so you would just go out to 4. Okay, you would just go out to 4 on this axis here. Okay, so those are the different ways that you would graph imaginary or complex numbers that have a real component and an imaginary component. So a quick piece there. I do want to talk about absolute value because that's going to come up in the assignment. An absolute value, when you talk about the absolute value of a complex number, absolute value of a plus bi, all you're doing is taking the absolute value, or when you're taking the absolute value, all you're doing is taking the square root of a squared plus b squared. So let me give you an example. If I ask you to find the absolute value of 3 plus 4i, then you're just going to do 3 squared plus 4 squared. And that would be the square root of 9 plus 16, which would be the square root of 25, which would just be 5. And that's your final answer. The reason that you do that is because absolute value is your distance from 0 in the coordinate plane. So if you look at this graph, 3 plus 4i is right here. So I'm actually calculating this distance, the distance from the origin out to there. Okay, I'm calculating that distance. That's what absolute value is, distance from the origin. Let me try another one. Let's say we had the absolute value of 2 minus 5i. So if I follow my formula, I'm doing the square root of a squared plus b squared. So I have the square root of 2 squared plus negative 5 squared. Remember, when you square a negative, you always get a positive number. So you should never have negative numbers under this radical when you're doing this. Ever, ever, ever. Okay, and then add them up, you end up with the square root of 29. You can't simplify that at all, so you're going to leave it exactly as it is. Sometimes you can simplify it, sometimes you can't. But that is the idea behind finding the absolute value of a complex number. Let's talk about operations of complex numbers. Like I said before, we can add, subtract, multiply, and divide. We'll talk about a few of the basic ones here. Let's talk about adding first. When we add complex numbers, so if I have 2 plus 7i plus 8 minus 5i. Actually, let's stick with plus for now. Okay? All I'm going to do is add my real components and add my imaginary components. So I'm going to add the 2 and the 8. That gives me 10. And then I'm going to add the 7i and the 5i. That gives me 12i. Okay, so very straightforward. Adding is very, very basic. Add your real components, add your imaginary. So add your A values together, then add your B values together. Same is true if you have a negative in there. Let's say I have 3 minus I plus negative 2 plus 6i. Okay, so I have 3 and negative 2 gives me 1. And negative 1i plus 6 gives me 5, so I have 1 plus 5i. Same rules apply when you're doing subtraction. So when you subtract, you just follow the same thing, right? You just have to make sure that you distribute that negative. And that's where sometimes people make careless mistakes. So for example, here I have 2 minus 10. So that would be 2 minus 10 is negative 8. Then I have 5i minus a negative 6i. A negative times a negative is a positive. So you end up with 5 plus 6i, which is 11i. Some people find it easier to change it to an addition problem. If this is easier for you, go ahead and do it. Change this to addition and then make sure you change the sign of everything after it. So I have 2 plus negative 10 is negative 8. 5i plus 6i is 11i. Okay, just make sure that you're careful with your signs. Negative 3 minus 2i minus negative 4 plus 7i. So I have negative 3 minus a negative 4, so that would be plus 4. Negative 3 plus 4 is just 1. I have negative 2i minus 7i would be negative 9i. This is where I see the most mistakes when people are doing subtraction. They mess up a sign in there. So make sure that you are careful with that. Okay? The other thing we're going to be talking about today is multiplying. When you multiply imaginary numbers. So we're going to talk about this in more detail in the next class, but be careful when you are multiplying. when you multiply, you can either multiply just an imaginary number by a complex number, 4 minus 6i, like this. And then you would just distribute. So here I would have 2i times 4 is 8i. I can multiply things that aren't like terms. That's okay. Now here's where you have to be careful. 2i times negative 6i is negative 12i squared. Make sure you are okay with that. We talked about this back when we first introduced the idea of imaginary numbers. And this is one thing that you need to make sure that you remember. So tattoo it on your brain somehow. But make sure you remember this. I squared is equal to negative 1. Make sure you know this. This is super, 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 super important. Okay, I squared is negative 1. That allows us to simplify a lot of things, and you're going to see how beneficial that is as we move through this, especially on Monday. I is just I, but over here I have I squared, so I can replace that with negative 1. I end up then with 8i plus 12, and I want to make sure I write it in standard form, in A plus BI form. So that's how you would want to write that. Okay, so when you're just multiplying an imaginary number by a complex number, distribute and then substitute negative 1 in for I squared and put it in the proper form. The other type of problem we have is when we're multiplying two complex numbers together. For example, 3 plus I times 4 minus 2i. Just like when you're multiplying any other binomial together, you're going to use the FOIL method, and I know that you guys are familiar with this. First, outside, inside, and last. Multiply your first two your first two terms together. So multiply the 3 and the 4. That gives you 12. Multiply your outside terms. You have 4 terms here. 1, 2, 3, 4. Multiply the outside terms together. So 3 times negative 2i is just negative 6i. I stands for, in FOIL, that's the inside term. So I times 4 is 4i. The L is your last two terms. So you have I and negative 2i. So that gives you negative 2i squared. There's a couple things then that are happening here. We can replace the I squared with negative 1, and we can combine those middle terms. So we have 12, then a negative 6i plus 4i is negative 2i. Okay? I squared is negative 1, so I'm going to replace that. I end up with 12 minus 2i plus 2, and now I'm going to combine my like terms. So I end up with 14 minus 2i. And that's how you multiply complex numbers together. If you weren't quite sure, because I went through that kind of fast, rewind the video and watch it again. You should understand FOIL already, so you should be okay with multiplying these together. The big thing to remember is this. I squared is always negative 1. Okay, you guys should be all set then with the assignment. Monday will be another video about more with operations with complex numbers, and then I will see you all in class on Tuesday. Have a great weekend, everybody. Bye-bye.